Today we are going to discuss physics problem 36. This is actually a continuation of our previous question, and we are going to use the same result that we got. The result that we got in the last discussion, we will be using it. Now here a large amount of material is to be lifted up, which is total weight is more than the limiting tension or the breaking tension of that rope. So we lift it in smaller quantities like m kilogram, smaller quantities, so that weight will be less than T newtons. So that means you have to make a number of trips to lift the entire material. So here in the question itself, suppose during each trip we keep to some equal amount of material, say small m kilogram, so that how we can minimize the time of the total process. That is the question. So let we denote by capital M the total load to be lifted. Total load to be lifted. Small m is the mass to be or material to be lifted in a single trip. So for which the time T minimum for this m kilogram be lifted. For m kilogram is to be lifted during each trip. So small n. So for that only we have got the minimum time. M kilogram can be lifted. M kilogram can be lifted with a minimum time of T minimum is equal. That is the result we got in the last class. So which says 2ht by T minus mg into g, square root of this. That is the minimum time for lifting and for a single trip of m kilogram. This can be lifted in this minimum time. So number of trips will depend on capital M, total mass, divided by m, number of trips. That also I will just make note here itself. Number of trips is equal to capital M divided by small m. So that many number of trips we have to make. So the total time will be the product of this minimum time for a single trip times the number of trips. That will be the total. That total time is to be minimized. So I will delete part of this question before I proceed further. I have written down the total time denoted by tau. Single trip, minimum time is this into number of trips. So total time is that. I square this, and also you can see the setup, the system involved, which I have explained in the last class. First should be accelerated with the maximum tension, and then allow it to come to rest under gravity. Those things on the diagram. Now tau is this. We square this. Tau square is equal to tau square. We square it for minimizing. It will be easier. 2ht by T minus mg into g. Here you can see certain quantities are constants. Capital M is a constant. This is a constant. Variable part is here only. So this implies tau square is equal to some constant k by this T minus mg into m square. This is the constant part we can ignore in the differential. This whole thing is to be minimized. So the differential coefficient of this must be 0 because that is going to be part of the numerator after the differentiation. So for T minimum, we know T is to be minimized. For tau minimum implies d tau square by dm must be minimum, must be equal to 0, which implies only the differential part of that we have to make use, m square into minus g plus T minus mg into 2m is to be 0. So that gives us 2t is equal to 3 mg, or the minimum m, that minimum for minimum time, what is the m? That is m is given by answer to our question is this. M is equal to 2t by 3g. That is our required answer for the minimum time. Every trip, this much of material is to be lifted. So if you want further, you can also calculate the minimum time for each trip. For this given m, what is the minimum time for each trip? As a note, because that is not part of the question, just if you are interested, you can work out minimum time per trip. Minimum time per trip. Say T minimum. You just substitute this is the minimum. This gives you the time, general formula. In this, you substitute for the same value in this, so that you get the minimum. Okay, this minimum time per trip means you have to use only this. So the T minimum will be 2ht by T minus 2 by 3 g. Mg is 2 by 3 T into g square root of the whole thing, which implies T minimum per trip. T minimum per trip is equal to 6h by g. You can simplify it and see it's 6h by g. So that is the minimum time per trip. But total minimum time depends on what is the total material given. That of course is not given in the question. So that was not required also. You just multiply by this to get the total time. So net minimum time depends on the total load to be lifted, which of course in case in some problem is given, you can work out. That's all. I think the rest of the explanation is clear to you. I think you can follow this. Thank you.